Hi, Assalamualaikum and a very good morning. So today we're going to do some tutorial discussion for chapter 12 and we're going to focus on the subtopic of 12.2 which is the chemical properties of the amino acid. And we're going to focus on the tutorial question 5, 6 and 8 respectively. So without any further ado, let us start. So for tutorial question 5, the structural formula of tyrosine is given as here. So here we're going to have an alpha carbon, where the alpha carbon going to be attached with the carboxyl group and amino group, and here is the side change of the R. Okay, and we have to predict the structural formula of the product when the tyrosine react with this following reaction here. Okay, so let us look one by one. So when the tyrosine react with the sodium hydroxide aqueous, where the sodium hydroxide aqueous here gonna be a base. So the base gonna react with the acidic part. Okay, and this gonna form a COO minus because the H plus gonna be taken by the hydroxide ion. So the hydroxide gonna take the hydrogen and this gonna forming a COO minus and Na plus gonna be close by to the COO minus. Okay, at the same time, the phenol group here, as what you can see, the phenol group here is also acidic. So you have learned about phenol in chapter 8.5. So you can see that the phenol, which is acidic, can also react with the base. So what's going to happen here is that the OH group here going to become O minus and Na plus as well. Okay, so a salt going to be produced. So the answer is we're going to produce a COO minus and Na plus. So please include the charge here. And the same goes to the phenol part here, where we're going to produce O minus as well as Na plus. Okay, so many of you will be forgotten about the phenol part here. So ensure that you are not missing that part. Okay, and now we're going to do the reaction of B, which is using HCl. So HCl here is an acid. So an acid going to react with the base. Okay, so the base is only have one part, which is the amino part. So the acid, the base here gonna be protonated into becoming a NH3 plus. The other part will still be maintaining. Okay, so what we're gonna get here is the tyrosine structure and the NH3 plus gonna be protonated. Okay, so that's for part B. Quite simple. And then now we move on to the reaction of C. Okay, so for the reaction of C, we basically mixing the tyrosine with the methanol in the presence of the concentrated H2SO4 under reflux. So the methanol are basically an alcohol. Okay, and here got a carboxylic acid group. So what we're going to undergo here is the process of esterification. Okay, so the C double bond O OH here, and here I can return it as HOCH3. So the OH part of the carboxyl can be removed, and the hydrogen of the alcohol can be removed, and this is going to be connected with the OCH3 in order to produce an ester. Okay, so it's going to be COOCH3, which is this part here. Okay, the other are still maintained. Okay, and because we are removing OH and hydrogen, the byproduct that we are performing is H2O. So we're going to eliminate water plus H2O. Okay, so now we're going to do the reaction of D, which is the sodium nitrite using the HCl. So this reaction here is the nitrous acid test, and this need to happen at low temperature, which is at 0 to 5 degree Celsius. Okay, so what's going to happen here is that the reaction of the tyrosine, which is an amino acid, with the nitrous acid, it's going to produce a salt, which is a diazonium ion, sorry, N triple bond N, and then here we're going to form COOH. So it's gonna form a diazonium ion, and then it's gonna have chloride ion close by to the positive charge. Okay, so this is a very unstable salt. Okay, so when it is unstable, the N triple bond here gonna be broken down in order to produce a nitrogen gas. Okay, so it's gonna remove nitrogen gas. At the same time, when it is being removed, it's gonna produce a carbocation here. Okay, so the carbocation here can react with water in order to produce alcohol. So the C plus here can be bonded with OH in order to produce an alcohol. Okay, so you're gonna produce an alcohol. At the same time, the unstable of the diazonium, the C, because it's gonna form C plus here, right? So it can also producing an alkene where the hydrogen here can be broken down in order to form an alkene, which is a double bond. Okay. At the same time, um, when it having a carbocation ion, which is C plus here, the Cl minus from the surrounding, which is the solution, can come here in order to produce a, come here in order to produce a haloalkene. Okay, and you know that we're gonna produce an alcohol, alkene, haloalkane, as well as the nitrogen gas. Okay, so for nitrous acid test, dealing with a primary amine, so this is a primary aliphatic amine, we're gonna always get four product here, which is alcohol, alkene, haloalkane, and the nitrogen gas. Where the other part you just copy back again. Okay, copy back. What changes is in the NH2 here. So you can change NH2 with OH, you can change it with Cl, and you can remove nitrogen and also make it as an alkene. Okay, so this is similar to what that you have learned in the chapter 11, which is the amine. Okay, all right, now we move on to the next question, which is tutorial question 6. So for tutorial question 6, we have to write the reaction between the phenylalanine, which is the IUPAC name here is given as 2-amino 3-phenyl propanoic acid, and glycine, which is 2-amino-ethanoic acid, in order to produce a dipeptide, which is the phe-gly. Means that it is a combination of one amino acid here and the other amino acid of glycine. Okay, so first we need to draw the structure. So let's say if you have a phenylalanine, which is 2-amino 3-phenyl propanoic acid, and the other friend here is glycine, which is 2-amino-ethanoic acid. So we're going to draw each of these molecule one by one. So for the propanoic acid, it's going to have 3 carbon. So we're going to have 1, 2, and 3 carbon here. And then at carbon number 3, it's going to be attached with a phenyl group, where the phenyl group going to attach with C6H5. Okay, so same meaning as here. And then at carbon number 2, it's going to be attached with the amino group. Okay, so the name going to be 2-amino 3-phenyl propanoic acid. Okay, at the same time, the glycine going to have the name of 2-amino ethanoic acid. So ethanoic acid going to have 2 carbon. And at carbon number 2, it's going to attach with the amino group, which is NH2. And the others going to be H and H here. Okay, so carbon number 1, carbon number 2, it have an amino group. Okay, so it is a reaction between phenylalanine and glycine. So now we're going to look on how we can write an equation in order to produce a dipeptide. So let's say if we have a phenylalanine here, and then we have glycine on the other part of the on the right hand side. Okay, so in order to produce a dipeptide, what we're going to do is we're going to remove the OH part from the carboxylic group, and the amine part here of the glycine amino acid, we're going to remove the hydrogen. Okay, so overall what we're going to eliminate is H2O. Okay, and as a result, the C double bond O and the NH here going to be bonded together in order to produce a amide functional group, amide class of compound, and then the single bond here gonna be forming a peptide bond, or known as the amide bond. Okay, so the reaction of the two um, amino acids here gonna produce a structure of like this, where the C double bond O and the NH gonna be formed, which shows that this is a class of amide. And then the bond here that connects C double bond O and NH of the other amino acid is known as the peptide bond. Okay, and the byproduct here that is eliminated gonna be water. And the structure here is known as phi gly. Okay, because the phi is on the left hand side and the gly on the right hand side. Okay, so this is known as the dipeptide. Okay, and di maksudnya dua amino acid dicantumkan menjadi satu molekul lebih besar. If 3 amino acids, then it's going to be tripeptide. If there's more than 30, then it's going to be called polypeptide. Poly maksudnya banyak, polygamy. Okay, so now we're going to move on to the next question. So for the third question 8, the structure of amino acid CC is as shown below. So this is the structure of CC, and the compound CC gonna react with the dilute mineral acid in order to form DD, whereas EE is formed when the CC is treated with the nitrous acid. And the condensation of 2 moles of CC will form a dipeptide FF. So we need to give the IUPAC name for the CC, and also we have to draw the structure of its switch ion, and we also need to draw the structure of DD, EE, and FF, and we have to show the peptide bond in FF. Okay, so what's basically question asking you to do is you need to give the IUPAC name of CC. So CC, we need to give IUPAC name. We need to also give the structure of zwitter ion, which is also written here. And then we need to draw the structure DD, EE, and FF. And then we need to show the peptide bond in FF. Okay, so the question needs to look at these structures here. Okay, and in order to understand what the question really wants, as usual, we need to come up with an idea. Okay, so if we were to read the question again, we can say that the compound CC, okay, will react with dilute mineral acid to form DD. So dilute mineral acid here can be HCl or H2SO4. Okay, maybe I will choose the HCl. So CC gonna react with HCl in order to form DD. Okay, whereas EE is formed. Okay, EE is formed when the CC is treated with the nitrous acid. So the nitrous acid is referring to the sodium nitrite with HCl at a very low temperature. Okay, so this is going to produce HNO2, which refers to the nitrous acid test. Okay, and then the condensation of 2 mole of CC form a dipeptide FF. So CC gonna form FF when there is another mole of CC, because dia kata kat sini 2 mole. So 1 mole and then another mole, 2 mole of CC, and then this gonna produce a dipeptide of FF. Okay, so by understanding this idea, we're gonna answer the questions once again. So for C, we have to give the IUPAC name. So the IUPAC name for this structure here is we're gonna do the naming starting from the carbon of the carboxylic group. So we're gonna have 1, 2, and 3 here. Okay, so 1, 2, 3 refers to the propanoic acid. Okay, and at carbon number 3, it is attached with the phenyl group, which is C6H5. So it's gonna be 3-phenyl propanoic acid. And then at carbon number 2, it's gonna attach with the amino. So it's gonna attach with 2-amino 3-phenyl propanoic acid. So this is the IUPAC name. Okay, so it's gonna be 2-amino 3-phenyl propanoic acid. Now we're gonna do the zwitter ions of the CC. So the meaning of zwitter ion is that they're gonna undergo internal acid-base reaction. So the internal acid-base reaction means that the base here gonna take up the hydrogen from the carboxylate part. So here gonna become NH3 plus and here gonna become COO minus. Okay, so here gonna become NH3 plus and here gonna become COO minus, and the overall charge here is still gonna be 0 because positive charge gonna be neutralized by a negative charge. Okay, so settle for CC. And now we're gonna draw the structure of DD. Okay, so DD happens when the CC react with HCl. So HCl here is an acid. So the part that gonna take place is the base. Okay, so the base here gonna accept another proton from the acid in order to form NH3 plus, and then it's gonna attach with a the chloride ion gonna be close by to the positive charge. Okay, and you're gonna draw it like this. Okay, so the other part is not affected, so you're gonna copy back again, and then the amino part you're gonna receive one proton, so it's gonna be NH3 plus, and the chloride ion which coming from the Cl here gonna be close by to the positive charge. Okay, so that's for structure structure DD. And now we're gonna do the structure of EE. Okay, for the structure of EE, this is a nitrous acid test, and as you know that this is a primary aliphatic amine. Okay, amine ni, nitrogen ni attached kepada satu alkyl group. So it's gonna be primary aliphatic amine because it is not attached with the benzene ring. Dia attached kepada carbon yang berchain, yang berangkai, bukannya dekat benzene ring. Okay, so this is primary aliphatic amine, and you know that when a primary aliphatic amine react with a nitrous acid, you're gonna produce 4 products. Okay, sama macam soalan sebelumnya. So what they're gonna form is a diazonium salt. Okay, so if you were to draw the structure again, you're gonna get it as CH2, CH, COOH, and here gonna be N triple bond N plus Cl minus. Okay, so here is known as the diazonium ion, which is, or diazonium salt, because it got a chloride. So diazonium salt here is very, very unstable. So bila dia unstable, the nitrogen gas gonna be the one that gonna be released first. Okay, so we're gonna produce nitrogen gas, and when the nitrogen gas is released, what we're gonna get here is a carboxyl ion. So the carboxyl ion here can react with water, and the OH gonna attach on this side. Okay, jadi yang NH2 tu digantikan dengan OH in order for us to form an alcohol. Okay, so we're gonna add with alcohol structure here. At the same time, they can also produce an alkene where the CH2 here can be expanded, which is H and H. So here gonna be broken down in order to form double bond here. Okay, so this one is another structure. And then for the last structure, we can also forming a haloalkane where the carboxyl ion here can also react with the Cl minus, masuk ke sini, and then it's gonna become CCl minus here. CCl here. Okay, so these are the 4 different structures that we can get for EE. Okay, and now we're going to do for FF. Okay, so FF is a reaction between 2 amino acid sama jenis. Okay, CC dengan CC. Okay, so we're going to draw the dipeptide where, let's say I draw back the structure here. Okay, so I have my CH2, and then I get my CH, and then I have my NH, H, here is COOH, and then one is H. Okay, so what's going to happen here is that the OH and the hydrogen of the amine going to be removed as a byproduct of water. And then the C double bond O here going to be attached with the nitrogen bond here. Okay, and this is going to produce an amide. Okay, so as what you can see, the C double bond O here going to be attached with the NH of the another molecule of CC. Okay, and the other part we just copy back again. And the connection between NH with the C double bond O of the CC and CC here gonna be named as the peptide bond. And the whole structure here is known as dipeptide. Pasal dia adalah pergabungan antara dua amino acid. So kalau dua dia akan jadi dipeptide. Kalau tiga dia akan jadi tripeptide. Kalau lebih daripada 30 it gonna be polypeptide. Okay. So in this case we have answered all the question where we have shown the peptide bond and we have also drawn the dipeptide. Okay. So I think that's all for today's video. See you again some other time. Bye.